which is part of Carlton Bates Company and Wesco Distribution's ongoing educational series for the oil and gas industry. Today's exclusive webinar content is sponsored by Phoenix Contact, one of the most preferred electrical component brands serving the oil and gas industry. Our presenters will be discussing the most pressing issues you face in securing field operations data and equipment while ensuring that adequate power is available to prevent downtime. Before we turn over the event to our presenters, let me run through a few logistics. This event is being recorded and your phone lines have been automatically placed on mute. Our event, however, is designed to be interactive and allow you to ask the questions most critical to you. At the end of the presentations, we will have time to address questions and comments. Please use the chat box or the Q&A panel. We will be monitoring both. You may also enter your questions or comments via Twitter using our hashtag. At twitter.com, enter the pound symbol followed by CBC Webinar. At this time, I'll introduce our first presenter, Troy Thacker. Troy is the Oil and Gas Industry Manager for Phoenix Contact USA. He has worked with oil and gas industry end users, engineering companies, system integrators, and distributors for 30 years. In his current role, he is responsible for the development of marketing and sales programs which promote and support sales for Phoenix Contact products to oil and gas customers. Working closely with Phoenix Contact's Solutions Engineering team, he regularly contributes to the development of new products and application packages that meet the needs of oil and gas customers. Troy received his electrical engineering degree from Lamar University in Beaumont, Texas. He has been employed with Phoenix Contact for 24 years and currently resides in Houston. Joining Troy today will be Mike Garrick, who is the Marketing Manager for Phoenix Contact's Power Solutions Business Unit. Mike's experience ranges from military simulation to industrial automation. His career at Phoenix Contact has spanned 20 years and has included expertise in machine safety, electromechanical control, low voltage power, and battery backup solutions. And Dan Schaefer, who is a networking and security expert with more than 15 years of experience, specializing in network design, security, and troubleshooting. Dan is a business development manager of network and security for Phoenix Contact. He holds a bachelor's degree from the University of Pittsburgh, various IT and network certifications, and is a member of network and cybersecurity organizations involved in standards writing for ODVA, APTA, and ISA. So at this time, I'll turn the presentation over to our first presenter, Troy Thacker.
Yeah, thank you. We're very excited by this opportunity to be here today. Thank you for joining. The top concerns of the oil and gas industry is the fact that they must manage many issues which impact business at all levels of their organization. Managing top issues in a positive and productive manner define the top goals of most organizations. Given the hazardous and volatile nature of the products these companies produce, coupled with the speed at which news about the major events can be disseminated, companies have become very sensitive to the impact they have on local communities and the environment. Most all have adopted a culture of safety and awareness and promote these concepts heavily within their communities, encouraging their employees and vendors to conduct their lives in a safe manner even outside of the company gates. Safety is the lifestyle of the modern petrochemical employee. Paying attention to safety issues has made it possible for companies to conduct business in environmentally sensitive areas, gaining access to rich reserves and exploring uncharted territory for new reserves. Expanding reserves and limiting government oversight, fines, the penalties, the excessive fees, and lawsuits are major goals of all oil and gas companies. All of these concerns are the driving factors behind corporate goals. After listing and looking at them, I was able to group them into 4 categories. The biggest concern is to provide. Companies must provide products and services in an unfailing and a safe manner, thus protecting their reputations, their profits, and their freedom of choice as to how they conduct business. A consequence of providing, companies make expanding and maintaining vital infrastructure a prime goal of their organization. Managing is the next major concern, and managing the movement of products and monitoring the health of systems, as well as efficiently managing assets and manpower, assure that companies operate profitably and safeguard their reputations. Gaining access to remote and environmentally sensitive reserves and then safely transporting the produced product to market are essential elements for assuring a profitable future for these organizations. Knowing the current status of inventories, having the ability to respond quickly to price changes, to spot market demands, and reliably to delivering contracts are vital for the profits of the organization. Maintaining a visual with continual updates streaming in from production points, points of sale terminals, analyzers, monitoring specifications, observing the status of operation conditions, spill monitoring, and timely submittal of mandated reports are all important for the organization achieving their goals and continuing development. A company's goals become their objectives when their reasons are moved to actions. And objectives then drive the need for the solutions. Phoenix Contact provides high-quality products and is able to deliver, ready to deliver solutions for every objective needing to be met. Phoenix Contact is a company devoted to the right technologies to meet the needs of industries. For example, highly reliable and robust power supplies help assure maximum uptime and availability to help deliver goods to market. Our fast and reliable logic controllers and industrial computers coupled with HMI displays and our PCWorks software create the SCADA environment needed to deliver vital information. We offer multiple options for accessing data in hazardous environments that are found in the field, and then networking and exchanging data across multiple communication platforms under harsh conditions while assuring secure lines of connectivity are our core strength, as we are an industrial control company. Working closely with our customers, we deliver key solutions to meet the needs of every challenge. As an example, wellheads by nature are prone to fire and explosions. They operate under harsh conditions, high temperatures, low temperatures, sand, grit, snow. But as the first stage of the production process, collecting and reporting data is critical in the organization. Equipment installed here must meet the rigors of the environment and keep users safe, providing reliable data and dependable data. This is true for all phases of the production environment, and Phoenix Contact is here to help you with the technology built around power, logic, I/O, and data. Speaking to power, we offer goal-setting solutions that assure continuous power for all conditions, assure reliable power, and are proactively and help proactively manage unplanned load changes as well as unanticipated conditions. Our logic makes automation easy for applications requiring control. We offer data loggers for collecting data, analyzing information, and providing SCADA capabilities. We offer I/O that extends your reach in hazardous areas for safety, and offer flexibility of interface that is reliable and safe, both wired and wirelessly. And for data, we provide secure and easy to implement data devices, network devices, giving you the opportunity to communicate across disparate generations of legacy data products. These are our areas of strength. So to begin, Mike Garrick is online, our power supply product manager. He wants to share with you 3 of our unique power supply technologies and how they're able to help you meet your needs. So Mike, I'll turn the keyboard over to you.
Thank you, Troy. Good afternoon. I'm Mike Garrick, and welcome to the Reliable Low Voltage Power section of this presentation. Today we'll cover the following areas of concern for low voltage power systems. For AC to DC power supplies, we'll focus on the reliability of the DC output and how the output is monitored. In this example, let's use a 24-volt, 10-amp power supply. If the power supply tries to provide over 10 amps, the reliability of the power system can be at risk, depending on the characteristic of the DC output. In a perfect world, as the system draws more than 10 amps, an alarm is passed to the control system. This alarm is the first warning that the DC bus is using too much current. A device could be getting old, or something has been added to the system. The power supply has gone into an area commonly called power boost. Power boost can be as high as 50% more than the nominal rating of the power supply. Please note that the power boost must be available permanently to improve the reliability of the DC bus. If the DC bus continues to draw more current beyond the power boost rating, the voltage will start to drop. If the voltage drops 10% of the adjusted value, the second and final warning is sent to the control system. Please know that at this point, the control system could still be running. However, any further current demand will bring down the system. In this area of concern, the power supply characteristic is known as overload. The next concern involves power systems with multiple circuits. The power supply must be sized such that when a load experiences a short circuit, the breaker will trip. It's desirable for the breaker to trip fast enough to avoid a power glitch that can be seen on other circuits. This glitch can potentially reset the controller, or if the breaker does not trip, the controller will be off. Here's an example of what happens when a standard power supply is not sized correctly. The voltage will dip, as shown in the blue line, and the current rises to where it can, and the breaker does not trip. If the power supply protects itself from the short, the breaker will not even trip using its thermal properties. To get a thermomagnetic breaker to trip, a power supply must be sized correctly once again. A power supply needs to be able to supply 6 times the nominal current rating of the breaker to trip it in the magnetic area of the breaker curve. So, for example, a 4-amp breaker requires 24 amps to trip. A designer can either select a standard power supply sized to trip the breaker or use a supply that's able to provide a breaker tripping current pulse. This pulse is 6 times the nominal rating of the power supply and lasts for a duration of 3 to 5 milliseconds. A 5-amp power supply with a current pulsed output can provide a 30-amp pulse to trip breakers. And this is certainly a value proposition. DC to DC power supplies are also important to a reliable power system design. They have certain perennial jobs. In this example, galvanic isolation is the functionality. Quite commonly, a load is powered from the same supply as the controller. If the load draws too much current or shorts completely, there will be a complete loss of control. Adding a DC to DC between the controller and the load ensures that this situation is no longer possible. If the load shorts, the DC to DC will alarm and report the failing device to the control system. Amplification is another common functionality for DC to DC. This functionality is required when there are long runs of DC wiring. As an example, using a 24-volt field device that draws 1 amp and wire with a rating of 0.01 ohms per foot, there will be a 1 volt drop for every 100 feet of wiring. As the wire run approaches 500 feet, the voltage drops to 19 volts where it connects to the field device. This voltage can be amplified using a 24 to 24 volt DC to DC to accept the 19 volt input and provide a solid 24 volts DC out to ensure the reliability of the DC bus. Regulation. It's a very common requirement for battery applications. As you know, as the battery voltage drops, the field device can be influenced at some voltage. A DC to DC will accept the dropping input voltage from the battery and provide a regulated output voltage to the field device. During the gradual drop of the battery voltage, the DC to DC is monitoring the situation, looking for 80% of the nominal input voltage. Once the 80% level is reached, the DC to DC will alarm, letting the control system know that any further drop in battery voltage will lead to a deep discharge situation. Okay, let's switch gears and talk about redundancy. When it comes to redundancy, there's an exciting new technology based on a MOSFET design. This device is called an O-ring redundancy module. The benefit of using a MOSFET-based redundancy module over a power diode-based unit is the much lower heat dissipation. An advanced feature of the O-ring redundancy module is also exciting. It's the ability to monitor the load current. This ability takes the place of an additional device in the power system. In a 10 amp redundant system, the O-ring module will alarm if the load draws more than 10 amps. O-ring modules also provide something called automatic current balancing, or ACB functionality. Over time, it's normal for a DC output to drift from a power supply to drift due to temperature. A drift will cause an imbalance, and one power supply will provide all the current, and its internal temperature will raise approximately 10 degrees C. 10 degrees C is the key number. At this raise in temperature, it will cut the life of the power supply in half. The O-ring module is able to control the MOSFETs and force even current draw from both power supplies, even though they have drifted. Once the limitations of the ACB has been reached, the O-ring module will alarm. Our last area of interest is uninterruptible power supplies, or UPSs. Newer industrial UPS technology has intelligence to present the battery's state of charge, remaining backup time, percent of life expectancy, and many other variables. There is also a battery charge display for at-a-glance information. The intelligence of the UPS is based on its ability to communicate with the battery pack. These battery packs have an internal electronics module, and in the diagram, that's where the arrow is pointing at the electronics module. The battery packs can communicate their temperature, charge, lifetime, and internal resistance, for example. For a smart UPS application in a remote area, an alarm is commonly set for 20% of the remaining lifetime. This alarm ensures that the battery is not replaced too soon or too late. Well, this is the end of the reliable power portion of the webinar. Thank you, and now I'll hand the baton to Dan Schaefer.
Thanks, Mike. Hello, everyone. My name is Dan Schaefer, and we're going to spend the next few minutes talking about Phoenix Contact's M-Guard product line and how it fills the need for industrial cybersecurity and connectivity. The M-Guard is Phoenix Contact's high-level networking product line, handling routing and advanced functions above what an Ethernet switch can do. The M-Guard has three core functions: network security via stateful, firewall, and anti-malware functions, routing and network address translation, also known as NAT routing, for connecting to the enterprise network or other zones or subnets within your plant, and a virtual private network, or VPN, to allow for remote connectivity across the internet and used generally for providing support or remote data acquisition. In addition, the M-Guard supports a wide range of other auxiliary protocols and IT features, including things such as DHCP, DNS, syslog, VLANs, and so on. I won't spend time on these extra functions today due to time constraints, but if you have questions on them, please chat them in. Why care about these technologies? Why worry about security or layer 3 functionality in your environment? Here are just a few reasons. First, Just like basic Ethernet technology and wireless found their way from the office and enterprise world to the industrial world, so too has advanced networking technology. The need for security, VPNs, and routing is now on the plant floor, in control cabinets, and out in the field. So make sure you choose the right rugged hardware for the job. Next, VPNs provide a way to connect remote knowledge to local operations and equipment. They allow you to link sites together to share process information and data, and to connect service technicians to remotely support equipment, update programs, and so on without getting on a plane and having to spend time physically on site. Finally, plenty of bad guys are discovering industrial control equipment, especially in the critical infrastructure areas, such as the power grid, water treatment facilities, and oil refineries. These controllers, DCS, and SCADA systems are now seen as potential targets to hackers, organized crime, activists, and unfriendly governments. The vulnerabilities and risks are public knowledge, and you need to be proactive in protecting your assets. Here's an interesting data point on cybersecurity. Intellectual property theft costs U.S. companies $250 billion annually. That's $250 billion. A very large portion of that, up to $70 billion by some estimates, is in the oil, gas, and hydrocarbon industry alone. That's serious money that directly impacts the bottom line. Security in your process and control networks is serious business that needs to be addressed as part of a sound operational plan. There's a lot of very valuable and proprietary information located on enterprise or business networks. These can include planning and scheduling, information about active wells and known reserves, and financial data. The servers and systems that house slices of this data often share a network with operational systems, which in turn communicate to equipment and devices on the plant or production network. If these production systems or the networks they're on aren't properly protected and isolated, you are giving potential bad guys a pretty easy attack vector. Tools and techniques like firewalls, network segmentation, antivirus, and system integrity monitoring help mitigate those risks. In addition to the importance of intellectual property and other sensitive data, you want a robust and secure network to keep your operation running. Downtime costs serious money, often $100,000 per hour or more, depending on the scope of an outage. And while hackers get a lot of play in the mainstream press, they aren't the biggest threat to system and production uptime. About 4 out of 5 cyber incidents are not intentional and malicious. They're caused by things like a bad network card or a ping sweep flooding packets and causing a broadcast storm on a network, or a network configuration change like a new VLAN or a tweak of topology causing connectivity to be lost, an accidental duplication or mistyping of an IP address, or an infected USB stick being innocently used to transfer files and carrying malware to the production network. All of these things are real problems that still cause real outages with real monetary loss. All of them are very preventable with some basic security measures. Here's a graphic illustrating some simple security principles. On the right-hand side is the enterprise network with a few PCs shown connected to it. On the left is a security appliance, such as the mGuard, acting as a firewall and a router, allowing only necessary connectivity to the industrial equipment attached to it. In this case, the production devices can communicate freely with one another, but traffic from the enterprise network is strictly limited. Because routers don't allow broadcast traffic to go from one network to another, all of the unnecessary traffic, such as Windows chatter and ARP broadcasts, will be blocked. If an enterprise device happens to get infected, say by some malware on a USB stick, that infection would propagate to the rest of the enterprise network, but would be blocked by the firewall functionality and anti-malware on the mGuard. These techniques are easy to implement and are examples of applying IT technology to the industrial world. Shifting gears a little from security to connectivity, I wanted to spend a minute or two talking about VPNs and discuss the benefits they can provide. A VPN allows for secure, encrypted connections between individuals, devices, or whole sites over the internet. There are a lot of uses for a VPN. Basically, anything you can do if you were on-site and locally connected to a controller or a network, you can do over a VPN. Most commonly in our industrial world, VPNs are used to allow engineers or technicians to connect in from home or an off-site office to do diagnosis of systems, troubleshoot issues, and update controller code or functions. They are also frequently used to connect remote sites together where traditional IT equipment or a dedicated point-to-point network does not exist. This allows the sites to communicate securely with one another and exchange data. VPN tunnels can be made with hardware or software clients as long as they speak the same protocol language. In the example shown, we see several sites securely linked together over the Internet using VPNs. This requires no other infrastructure than a basic Internet connection and is a lot more cost-effective than running dedicated fiber or using a T1 or other point-to-point link. In this case, all the sites are tunneled back to a central location or hub site, but they could just as easily be meshed together. At the top right, we have a technician also tunneled into the central hub, and from there, he or she would be able to connect to and support all of the locations. One advantage of this model, where there is a central hub off of which several sites are connected as spokes, is that the only IT intervention or activity necessary would be at the hub site, configuring their enterprise connection to the Internet to allow the tunnels in. All of the other spoke sites require minimal, if any, configuration or network changes. So I opened with a slide on the mGuard product line, and I'd like to circle back these next couple of slides to talk a little more about it. From a development and design perspective, we strived and continue to enhance the mGuard line following three primary goals. First, we realized we didn't invent the concept of firewalls or routing, but we want to provide those essential functions as well as other high-level and advanced networking features in a variety of industrially rugged hardware variants that are comfortable and capable of working in harsh environments and the plant floor. Second, we want it to be interoperable and compatible with existing network equipment, especially on the IT side. Since we are often used to connect the enterprise or IT network to the industrial network, the mGuard needs to work with IP protocols. To achieve this, the mGuard supports all the IETF and IEEE protocols and standards that IT equipment does, things such as IPsec for VPN, VLANs, quality of service, and so on. Finally, we're easy to use. While IT gear can be notoriously difficult to configure and support, often requiring special software, for the mGuard, everything can be done via a normal web browser without the need for any sort of special configuration software. The mGuard has a stealth mode in which it can be dropped into a network to protect the devices behind it without having to modify or reconfigure those devices' network settings. Again, in a nutshell, we're just meant to be easier. From a variant standpoint, the mGuard comes in DIN rail-mounted versions, PCI cards, and even USB-powered personal variants. It supports a wide temperature range, DC power, and industrial resistance to RF, EMI, shock and vibration, and so on. From a media standpoint, the mGuard supports both copper and fiber with speeds up to 1 gigabit. There are also some handy hardware features, like a hardware alarm contact to monitor power and link status, and external memory for easy configuration and backup, as well as a hardware connection to start and stop VPN tunnel connections. Here are some of those variants flipping through your screen now. To conclude, when talking about security in particular, this situation isn't going to change, and the problem and risk isn't going to magically go away. Don't put your head in the sand and try to remain blissfully unaware. You need to be proactive and reach out to your friends at Carlton Bates and Phoenix Contact for a solution to help. So with that, thank you for your time, and I'm going to send it back to Troy.
Yeah, thank you, Dan and Mike, for your detailed discussions about the products and how they can benefit our customers. I want to take you now on a brief walk through some of the solutions that we offer. Beginning at the wellhead, Phoenix Contact offers the ability to capture information at the wellhead with our data logger. It's an application using our ILC 150 series controller. It's preloaded with application function blocks for recording data. We can configure this unit to capture multiple points of data, recording trends and changes for as long as 35 days, saving information in the form of a hard card, and allowing you to upload it to the network, the data up to the network, or manually pulling the card and inserting it in a computer at the pad site. Integrating it with a data radio, this becomes a standoff unit at the pad site and is backed up with a DC UPS power supply, which can be configured to meet your dark day requirements and specifications. This can be joined to alternative power sources like solar cells, windmills, other mechanical generating equipment to meet your uptime needs. This product is offered as a REL assembly, or it can be installed in a box solution as you might specify. Moving to the separator section of a processor or of a pad site. Separators are an essential vessel for producing gas and oil according to contract specifications. They are simple in operating principles, but have a large number of I/O points and are complex in their instrument control technologies. They are sometimes connected in trains in order to improve or to meet tighter specifications. Given the volatile environment of the petrochemicals found in this vessel, its alarming points are often monitored and maintained with a strong vigil. So the unit we offer basically uses an ILC 100 series controller and can help manage and communicate the alarm conditions and communicate with the RTU through a data radio. Again, also using intrinsic I/O in those environments that are configured for it, you can work around the Class 1 Div 1 type of installations. Looking at compressors or any number of compressors used on pads or in a process environment, each having their own unique characteristics and control ramifications. In this type of environment, we offer, again, our ILC controllers. In this instance, a ILC 200 series controller with the appropriate I/O. Interconnected with data radios allow for Wi-Fi connectivity that allows local user access for monitoring conditions as well as uploading to a backhaul network. We would integrate that in cooperation with a network switch and perhaps an mGuard for security as those users might want to specify. Looking then to the pipeline solutions that we offer, again, we look at our data radios and ILC controllers. In this particular example, we would configure a SCADA layout using an ILC 300 series controller with the suitable I/O arrangements through our networked data radios. Allowing you to communicate over long distances, any number of configurations required for monitoring the safety of a pipeline, whether it be cathodic protection, leak detection, or general maintenance issues on the system. Moving then to tank farms, we offer a tank farm monitoring system based on an ILC 300 series controller with the I/O, again connected through remote connectivity of radios with the appropriate I/O attached. So as each customer has unique requirements, we would lay these out according to their needs, and then with our application software help monitor the high and low levels, as well as perhaps even moving bulk materials. Looking to hazardous locations, Phoenix Contact, being an ATEX or an IEC organization, works with the intrinsic safe I/O barriers and can help cross from your safe zones up to zone 0 applications through our intrinsic I/O. So regardless of what controllers or what applications you might have to deal with, we do offer a mix of I/O that helps create a safe environment. Then looking lastly here to the metering aspects of systems. They are highly networked with multiple nodes, very vulnerable to the security issues that Dan was talking about. And here we would try to incorporate our security routers in the control scheme as a user might want specified. So from a solutions perspective, we try to offer opportunity to work with you in the power, logic, the I/O, and the data areas of your applications. We offer a number of solutions designed to meet your needs. We really want to help you achieve your goals as we partner with you. That concludes the basic message for this session. I would open it now to any questions if anybody should have some.
Thanks so much, Troy. What a great presentation by you, Mike, and Dan. We appreciate you very much. Let me just remind the audience that you can enter your questions into the chat box here. We're monitoring that. Also on Twitter, you can enter a question using hashtag CBCWebinar. So let me just go ahead and take our first question for you, Troy. Does Phoenix Contact offer off-the-shelf solutions?
Well, yeah, solutions, by their nature are somewhat customized to customer needs, but we do offer a collection of components. As an example, our Radio Ready box is a package a customer can buy, and it has room to install the PLC and other components, and comes pre-packaged with the power supply, the surge suppressor, and terminal blocks and circuit breakers. So it's a package that has done most of the basic engineering, but needs to be finally configured by whoever is trying to implement a solution. From there, we do work with customers to formulate a package that will meet their needs, and then we would work with our local distributors, as in this case certainly Carlton Bates, to configure a package that the customer is looking for.
Great. Well, let's answer another question here. This one is for Dan. Do I need a firewall at every device or just one for my network? And where should I put it?
It's a good question. If you think of network security almost like where do you put smoke detectors in your house? You can put one in every room and every hallway and in the foyer, and that is maximum protection. It might be more costly. It might be a little overkill. It might not be really what you need. You could swing the pendulum the other way and just put one smoke detector in your house and say, hopefully wherever the fire starts, it's close enough to the detector that it goes off. So the answer is usually somewhere in the middle. What I would recommend is you definitely want a firewall protecting your link between the automation or production network and the enterprise network. But then you could also use a firewall to give additional protection to those most critical pieces of your network, or you could break it down by individual cells. So there's a little bit of soul searching and navel gazing you might have to do to find that sweet spot between cost and effectiveness. But a good guideline is one per production cell, and certainly one at the connection point to the IT world.
Great, thank you for that. So let's pass it back to Troy for another question. How does Phoenix Contact decide to develop a given solution?
Well, primarily, it's from customer input. We'll sit down with them and work with them on the particular problem that they're trying to meet, and then look at the possibility of maybe cataloging that opportunity to see if other customers might have an opportunity for similar circumstances. So to bring it into a formal solution, fundamentally we need to work with a customer. From a concept of no idea to a product. But once we have a solution to offer, then we would anticipate what customers might have a need for that, and then share with them our capabilities for perhaps helping them with similar problems they have, and networking that back through our distributor network.
Great, excellent. Let's give one to Mike here. Are there concerns for redundancy on the AC side of the power supply?
Yes, absolutely. Not only redundancy, but redundancy with diversity. This means that one of the redundant power supplies will be fed with a standard utility-based AC feed, and the other perhaps with a generator or some kind of battery-based inverter solution, possibly solar, charging the battery through inverter, and used as part of the redundancy with diversity. Thank you.
All right, excellent. And let's wrap up with one more question for Dan. How do I know if I'm infected or if there is an attack on my network?
This is a lot harder now than it used to be. Hackers used to be very noisy. Now they are much more interested in stealing data, your valuable intellectual property type information, than just wrecking stuff or sounding the alarms. So there are a lot of logging tools that you can use. There are tools called IPS, intrusion prevention, and IDS, intrusion detection systems, that can help you notice when things are going awry, when things are off the baseline of your network. So basically, it's you need to be very aware of what's going on. You need to know what your network looks like, what it has in it, and what typical traffic looks like. And then somebody has to be monitoring it. It's not something that can just happen. You have to take the time and effort to do it. And really, there's no other way. You have to be active and involved in your network and watch your logs and be proactive in your monitoring.
All right. Well, what a great presentation today. For all of our audience members, any questions that we were unable to answer here due to time constraints, or those of you who have requested personal contact, will be followed up with after this event. And again, you will also be receiving a link to replay the video in the next few days. Thank you all for being here, and we appreciate you for attending the Carlton Bates Educational Series for the oil and gas industry.